Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic Numpy. Numpy stands for Numeric Python, which is a Python library for the computation and processing of multidimensional and single-dimensional array elements. It is a fundamental package for scientific computing with Python. Numpy provides various powerful data structures implementing multidimensional arrays and matrices. Numpy provides a convenient and efficient way to handle vast amount of data. Numpy is a Python library and is written partially in Python, but most of the parts that require fast computation are written in C or C++. Numpy, a replacement to MATLAB. Numpy is often used along with packages like SciPy and Matplotlib. This combination is widely used as a replacement for MATLAB, a popular platform for technical computation. Advantages of using NumPy for data analysis. NumPy performs array-oriented computing. It efficiently implements the multidimensional arrays, performs scientific computations. It is capable of performing Fourier transform and reshaping the data stored in multidimensional arrays. NumPy provides the inbuilt functions for linear algebra and random number generation. Python NumPy array versus list. We use Python NumPy array instead of list because of the following reasons. The reason to choose Python NumPy array is that it occupies less memory as compared to list. It is fast in terms of execution. At the same time, it is convenient to work with NumPy. NumPy array with list. Creating NumPy array with the help of list. Simple print command to print the array elements with rank 1. Endim can be used to determine the dimension of the array, creating rank 2 array elements with the help of list. Once again, printing the array elements, that is array with rank 2 is nothing but matrix. Print the dimension of array, that is array with rank 2 dimension, that is a row column based, and you can observe the result array with rank 1 and array with rank 2. Now here you just follow the procedure to create NumPy array with the help of list. Python program to demonstrate NumPy arrays with the help of tuple. For that, import NumPy as NP. ARR is the name of the variable. NP dot array. It is the method to create array with the help of NumPy, and this is the process to create Numpy array with rank 1. You just go through the procedure and printing the array elements and printing the rank of array elements. And the next is creating rank 2 array elements. You can follow the same procedure. Just go through the syntax to create array with rank 2 with the help of tuple, and once again printing the array elements and rank of the array elements. You will get the output as shown: array with rank 1, array with rank 2. Numpy item size, data type, shape and reshape. You will get the item size of integers in bytes. You will get the data type, that is integer 32. Dimension of the array, it is 4 by 5. You can reshape it to 5 by 4 also with the help of reshape, and it will be assigned to the matrix B. You can print the matrix B after reshaping. Accessing array elements. Accessing array elements with the help of row column index. That is the row column index starts with 0, 0. Here 0, 0 means first row, first column. 2, 1 means row with index 2, column with index 1. Like that you can access array elements. Accessing numpy array elements. For that, import numpy, define the matrix. Here printing the matrix. We are accessing array elements by specifying the matrix name mat1 with I stands for row index and j stands for column index. You can specify the row column index to print the elements present in the matrix. Accessing row elements. Accessing row elements can be done just now as we did. A small difference: to access a particular row, specify the index of the row, comma, colon indicates all column elements will be selected. By specifying 0, it will print first row, 1, second row, 2, third row. Here you can access the array elements with the help of the syntax. Accessing numpy column elements. By exchanging the previous syntax values, we'll get the column elements, that is mat1. Just now we discussed I comma j stands for row, j stands for column. Now here, to access first row elements, all rows comma column index, it will print the first column elements. Replacing 0 by 1, it will print second column elements, and colon comma 2, it will print third column, colon comma 3 indicates fourth column elements. All row elements, and it is the index of column. All row elements comma column index. By specifying the column index, you will get all column elements as shown. First column, second column, third column, fourth column. Like that you can access. Here the colon indicates all row elements. Principal diagonal elements. You can consider any matrix of 4 by 4 or 5 by 5 or 6 by 6. The primary diagonal elements are 0, 0, 1, 1, 2, 2, 3, 3. If it is 4 by 4 matrix. And to access the principal diagonal elements, we have to apply the condition I equal to j. And to access the secondary diagonal elements, uh, the secondary diagonal elements are A03, A12, A21, and A30. And these elements can be accessed by substituting the condition I plus j is equal to n minus 1. Accessing principal diagonal elements, for that matrix definition, order of the matrix, defining a function, and printing a simple print command which displays the principal diagonal elements. And to access the principal diagonal elements, here we are using nested for loop. That is, for I in range n, for j in range n, means the first function will point the row elements, and the second function, nested function, will point column elements. And here, when the row equal to column, it will print the elements of the matrix, and end equal to, in quotation here we are providing some space, means the output will be uh, displayed in a single line with some space, otherwise the output will be displayed vertically in this fashion. If you want to use end equal to statement, it will print the output integer values as shown in this fashion. To print the values in a single line with some space, we can use the syntax end equal to. And this is the condition for principal diagonal elements accessing procedure. Accessing secondary diagonal elements, you just simply replace the condition. If I plus a double equal to n minus 1, you can simply access the secondary diagonal elements. Simply replace the condition and once again check whether you are getting or not. Line space returns evenly spaced numbers over a specified interval. A equal to np dot line space 1 comma 5 comma 9 means it will print 9 elements equally spaced between 1 and 9. You can observe it prints the elements 1 to 9, yet 9 number of elements gets printed. Here it prints 9 elements which are equally spaced between 0 and 1. Arrange method. Arrange method prints numbers from 0 to 2. Here we are specifying 0 comma 2 comma 0.1 means it prints all the numbers from 0 to 2 in step of 0.1. You can mention the starting number, ending number, and step size. 2 will not be printed up to 1.9. It prints the value. You can determine the minimum, maximum, sum, square root, and standard deviation of the array elements which are uh, defined. You can define the array element with the help of list or tuple, doesn't matter. Numpy for sorting arrays. You can sort elements of numpy You can sort the elements of NumPy with the help of sort function, and you can observe the result. Sample methods available in NumPy. You just go through a number of application you can develop with the help of NumPy methods. Few more methods you can calculate different application based problems with the help of the methods provided. Few more. Thank you. We will meet with the next lecture.